So I wanted to go through this example because I know a few people have asked about the examples I did in the lesson last week. So you'll notice that on the page that I gave you to do, I put in a table and some structure for how you should follow it, especially if you're going to be using the formula. So we've got our y coordinates. It's a bit confusing because it starts with y0, that being the first one, okay? Then it's y1, which is technically the second, third, fourth, fifth and sixth. So here you've got the x coordinates, and they obviously come from here, so 2, 4, 6, 8 and 10. For the formula, you need to have the corresponding y coordinates. So our first y coordinate is the second number, so along the corridor and up the stairs, and that's 0. So I put 0 in here. The next y coordinate is 18, so I've put 18 here. 19, 16, 7 and then 0 again back at the end, so it touches down to the bottom. So then I've put in a couple of questions to help you work through the formula. So the width, so it should say width, not the width. The width between each strip is considered to be the height, because we know we talked about it in the last video, where if you put it on its side and you were to join these up, then obviously you've got your trapeziums there. Okay, so the width between each of those strips is the height of the trapezium, and in this case that's 2. So here's the formula. The formula is half times the height, and then you multiply that by your first y value and your last y value, so that's n. That would be the last one. This is how the formula works. And then 2 times all of the middle values up to this one. Now yn minus 1, if yn is our last value, then yn minus 1 is our second to last value. Okay, so the one before the end, second to last. I did redo the formula with these values of y so you could see how it works. So y0 is that 0 there. Our last y value is y5, okay, so again that was also 0, so I substituted 0 and 0 into the formula. Then you've got y1, y2, y3 and y4. Those are all of the middle values. So again, these ones here were the middle, this one here was the last, and this one here was the first. So that's how the formula works. Pop in all of those into your formula and then into your calculator, you get an answer of 120, and because this is a sort of speed time, that is going to be meters. If you worked it out by doing the trapeziums, well, on the first one, if you notice the shape that you get there, it actually creates a triangle. So you can do base, which is 2, times by height, which is 18, all divided by 2, so it's base times height divided by 2 for a triangle, so that first one there is 18. For the second one, okay, that is a trapezium, so you've got a plus b, so that would be 18 plus 19, times by the height, which is 2, and then it's all halved anyway, so that gives you the 37. Likewise for this one, it's a trapezium, so 19 plus 16 times by the width, so the difference between 4 and 6 is 2, and the formula for your trapezium, so that was a half times by the height times by a plus b, and that generates 35. The next trapezium generates 23, and then at the end you've got another triangle, so you'll get 7. Adding all of those ones up together, you still get that same answer of 120. So that was the first question that I asked you to do out of the set. So moving on now to the second question. So in this question you're given the graph. I've written the formula at the top for each of these questions so you don't have to look back through them. And I just went through to start off with, and before I did anything, I went through and I looked at what all of the y coordinates were and I labelled them. So my first y coordinate, when you've got x equals minus 1, and the reason I started at x equals minus 1 is that in the formula, or in the question, it says to start from x minus 1 up to x equals 3. So when x is minus 1, y is 6. At 0, it's 15. At 1, my y value is 12. At 2, it's 9. And at 3, it's 18. So if you pop all of those into your formula, the first value for y is 6 and the last value is 18. So here's your first value. So that was first, 18 was the last, and these ones here were all the middle sort of values. So when I pop those into the formula, that's where they go. First, last, and then 2 times the middle values added together. The height in this case, so the width between each of my ordinates, is 1, and then the formula also has a half in there, so it's a half times that height. So I got my answer there to be 48 units. If you've done it using the other method, these are the values that you should get. So it would be on the first one here, first trapezium, is a half times by 1 times by 6 plus 15, which is where you get 10.5 from. This trapezium here, so if I just shade that in so you can sort of see, that one is a half times by 1 times by 15 plus 12. And then you continue on doing it, so this is a half times 1 times by 12 plus 9, and then the final one, half times 1 times 9 plus 18. So those are the values you get, and you see that you get exactly the same answer. So as I said, you choose which method you prefer. Question 3 I then asked you to do. Okay, if I just go back. So for question 3, this was the one that you were given for there. You were asked to find it between x equals 0 and x equals 4, and it tells you that you're going to go every 1 across. So if you're using the formula, what I started off by doing was writing down all of my values for y. So it intersects the y-axis at 26, that's my first value. That value was 35, that value was 33, 20, and then here at the end it was 0. Okay, so that coordinate there is 0, 0. So my first is 26, my last is the 0, and then the 35, the 33 and the 20, they all count as the middle values, so they went into that part of the formula. So half times 1 times by 26 plus 0 plus 2 times the middle values, which gives you 101 units. If you were doing it as a trapezium, the first one here would be half times by 1 times by, so those values added together, 26 plus 35, so you see you get 30.5. Doing that on the next one, half times by 1 times by 35 plus 33 gives you 34, then you get the 26.5 and a 10. Again, that one's a triangle, so you can just do base times the height divided by 2, and you get exactly the same answer. So those are the 3 questions that I went through in the meeting last week, and then the one final point that I just wanted to make was that when you have a velocity time graph, that the area under the curve is equivalent to the distance. So with this question here, question 5, it asks you to estimate the distance that the particle travelled, and so to estimate the distance, that means that we're going to have to use the trapezium rule. It does tell you that in the question here, but it won't always do so. So just a quick run through. When you have done the other questions, these are the ones that I got. So it's up to you whether you want to pause the video now, have a go at the questions and then check your answers. But for question 4, I got 183 litres doing it that way, or 183 doing it using the trapeziums. Question 5, I made a mistake here when I put it into the calculator. 1.5 times by 26 gives you 39, so that's using the formula. If you did it by splitting it up into, well, 2 triangles and a trapezium, those are the values that you get for the 2 triangles, 12, 7.5, and that's for the trapezium, so you also get 39 metres. For question 6, I again made a mistake here, and then I emailed you guys once I'd made that mistake myself. So although this counts as 30 minutes, the velocity here is being given in kilometres per hour, so we need to change the 30 minutes into hours. So 30 minutes we know is half of an hour, so that's 0.5. So we've got a half times by 0.5 times by these values, which is 15.75 kilometres. Or if you're doing it the way with the trapeziums and the triangles, again, that's the values that I get there. And you'll notice that what I've done with my questions here is I've split it up A, B, C, D, so you can see what each of those corresponding values are for A, B, C and D. Question 7. I've got those values for my y starting at 0, so that's the first, that's the last. 14, 29 and 26 are my middle values. So I got 168 metres that way, or 168 metres if you do it this way. And again, you can see I made a little mistake there, but it's quite easy to check. Question 8. It says, I've put here, read the scale carefully. So between your points you've got 1 hour, and again this is in kilometres per hour. So when you're putting in the value for the height, that is going to be 1, not 60 minutes. You know, and it asks you to use the points 2 o'clock, 3 o'clock and 4 o'clock, so that's why I've just got the 1 between each of those. It doesn't actually ask you to go up to 5 o'clock, it asks you to stop at 4 o'clock. So you'll see on mine, to stop myself from making that mistake, I did cross off this last bit because I needed to ignore it to do this question. So the answer that I got there was 25 kilometres, and if you did it in 2 parts, you still get 25 kilometres as your answer there. So, final set of questions. This question did it again. It asks you just to estimate it for the first 40 seconds. So I scribbled off this bit here because I didn't need it. I've put my readings on here. Obviously it's starting at 0, so that's my first value. So that was my first point, that was my last point, and those values there came from my middle points here. So it's 97.5 metres, or if you've done it bit by bit again, there you are, 97.5 metres. Question 10. So question 10 and 11 are really tricky because for these you need to actually generate the graph first. So you're given the formula 6 plus x minus x squared, using the calculator and using the calculator very carefully with a -2. So for example, for the first one, to get my y value, I typed into the calculator 6 plus a -2. Take away, and then I used brackets, -2 squared. You must remember to use brackets when you are squaring a negative number on your calculator, otherwise it won't work. So these are the values that I got. I plotted those onto my graph and joined it with a curve. It's got an x squared in it, so we know that's going to generate a curve. And then it wanted me to do the trapezium rule just between 0 and 3. So again, if you're drawing this for a question, I wouldn't then scribble it out, but you can see here I've labelled A, B and C to show you the section that we're working through. So using the formula, that's 13 units square, that's how it looks, or doing it bit by bit, if you've done it that way, 13 units square. The last question was the same. So here we have the last question. I had to find the values first to make the graph. So I substituted them in. You can see I made a table here, found the values of y and plotted those. Then it asked you to calculate the area sort of underneath. So my first value was 0, my last value was 0, and then the middle values you can see I've got here. There is a lot of repetition here. Put it in, you get that. And because there's lots of repetition, the shapes are the same. Here I've written A is equal to H. So the area for A is 3.5, but if that's equal to the area for H, that's another 3.5. I've just doubled my answer. B is equal to G. So calculating the area for B was 9.5. It's not very clear there, it's kind of become part of the 5. I've got 2 of those though, so I've got 19. So again, just what I mean is B has got the same values as G. So if I work out the area for B, I have by proxy worked out the area for G. So I've done that for each of these. C is the same as F, D is the same as E, and when I put all of those together, I get the same answer. So that's just a little run through on the trapezium rule.